Me again. I cannot hear you. Nope, still no.
It'll take a while. Take a while.
That's good.
There we go. It's a preamp. Literally, it's valves warming up. Uh, it's nice, right? It's only a little one, but it's actually got valves in it, so yeah, I feel good about that. How's Sauce Fusion, Sam?
It's good. It's been really interesting so far. It is a little bit lighter. I suspect they were expecting for attendance. That does mean I'm having really great conversations with CISA because we've got a lot of free time. So Defense Unicorns is the primary sort of vendor, announcer, speaker here, which is good. It's interesting, getting a lot of insight into Kessel Run.
Nice. Glad you're having an interesting time.
Yes. And I gave my talk yesterday going over all of our now 13 projects.
I saw a picture of that. Yeah, well done.
And we've got the 3 mentorship opportunities available now. And I tried to advertise that in the one room where we might have engineers ready for it. So
actual engineers. Whoop. Good. Excellent. Very pleased to hear it. Thank you. Hi, Mark.
Hello. Still fighting with my computer's audio a little bit here, so please be patient. For some reason, my headphones don't make my computer happy.
Mark's
Anyway,
also waiting for the valves to warm up.
The mouse to warm up?
Valves.
So I have a preamp which actually has a valve in it, and so the valve takes a while to warm up. So I turn it on, and people think, "No, it's not working. It's not." Oh, it is working now. So it's quite cool.
All right. Okay. So let's talk. Does anyone have anything to start with? Otherwise, I will start.
Just the 4 of us, it seems. So
I see. Yeah, I talked to Dr. Fina, I think, about talking here about MITRE and confidential computing. I mean, that's analysis that needs to be done. And I know, Steve, you said you guys have done it. It would be good if you perhaps, yeah, I would look over it. I think you even provided a link at one time. I would like to see it because I think we really need a better understanding of the security guarantees because you cannot really say you meet certain control obligations without understanding, like more detailed understanding of security guarantees. And on top of the list for me, actually, confidential VMs. Because I think confidential computing can massively overpromise and underdeliver on those, just because of extensibility, because of the large TCB, and it's something that I think we need to figure out how to provide guidance to actually getting a result. Like I refer to this mechanism like security pixie dust. You apply smattering of controls and things, and eventually you're wondering why your house of 3 walls is cold. So, all right.
So we had MITRE here in the last meeting, and had a good conversation.
Oh, I wasn't there.
No.
Okay.
But
there was a recording, so I can go back and watch it.
There is a recording. It was just Sal, Mike, and I on the conversation with Mari from MITRE. We do need to do follow-up on that. And we did a white paper a long time ago now on MITRE, and probably need to update it in the context of CVMs instead of in the context of SGX. Yeah. But the reason we haven't updated is it took a stinking long time to go through all the different MITRE attacks and kind of write down what we thought the impact was against the MITRE attack.
So who is we? Is this Anjuna
It was in
Basically,
June.
Oh,
Yeah, sure.
Yeah.
hi, Mari. Welcome. I did not realize you guys had a discussion last time because I said, okay, there's no meeting. I kind of felt bad because I saw that there was a recording. Your face was on the recording, and I was like, yeah, okay. Anyway, but yes, I would like actually, if you're saying there is a follow-up, I would like to start with that follow-up because we have Dr. Spina here. So can we maybe start with that?
Well, when you say follow up, I'm not quite sure what you're referring to.
Well, that's what Steve just said, that their follow-up needs to happen after last week's the discussion from 2 weeks ago on MITRE and confidential computing.
Well, I think it's worth redoing the white paper that we did and Juna did in the context of CVMs. And you know, I'm happy to make that part of what the CCC does as well. Last time we did it, it took us months to walk through it. It wasn't a full-time effort. It was grab a couple hours here, grab a couple hours there,
Right.
and work through the entire MITRE matrix.
Yeah. Yeah, no, this dovetails with something we're doing at work right now. So our data protection team is looking into confidential computing for a number of scenarios and started looking into MITRE attacks. And I went in and I compiled a little table, which I believe I forwarded to the mailing list of what like my thoughts on about a dozen of them. But I know it's incomplete. I know it's incomplete because it was more like scattershot, looking at a subset. But I think we do need a sort of a consortium's official stance on confidential computing in MITRE, and it needs to be one of the documents that we publish. And it can be out of this SIG for all I care.
Yeah, so I think the document we did with CSA, it's that same kind of exercise. It's just with the each of the MITRE attacks.
Mary, do you have thoughts on this? You're muted.
Muted.
Sorry. Okay. Sorry. Sorry. So I'm struggling just a little bit to follow. I'm very familiar with attack. I didn't know that we had looked at or someone had looked at confidential computing against attack. That's probably a good idea. Maybe, yeah, it's a good idea. We also have the MITRE Cloud Security Alliance caveat, which is more focused on cloud, might consider. We found a new attack called CPU stepping that is now addressed in caveat that and it's open for review. So it's kind of a new found in research. The difference between the caveat, cloud adversary vectors, exploits, and techniques or tactics, something like that. That's what caveat is. Attack will only publish those threats and attacks that are seen in the wild and confirmed, whereas caveat will do the researchy ones that are also predictive in nature, theoretical in nature. So there might be some value there. I built a very simple model on threats. I don't know, I think I showed it last week, or I can show it again. You know, I don't know if that's something we can use. I did publish it. Should I show it real quick?
Why not?
Okay, let me see if I can find it. I had it up and it was encumbering my screen, so I shut it down and now I want it back.
So what's the way?
Okay, here. Should be coming up now.
Whilst we're waiting for that, can I just ask a side question to the group, not on MITRE at all, which is that, is anyone aware of any current work on using TEs for GDPR compliance? I know we talk about it a lot, but has anyone seen anything concrete? I'd love to know if so.
Haven't seen anything in the wild.
Okay, thank you.
Did you get a LinkedIn request about it? Are you trying to write a report on it? Or do you need it independently?
I couldn't comment.
Sounds good.
Okay. This to me lays some of the groundwork. At least maybe the broad categories. And could definitely, I'm sure, be potentially be improved. I would think that we might want to publish a threat model at some point. I don't know. Maybe confidential computing in and of itself gets its own threat framework.
So this is
we
There's a
might
lot to
consider that.
yeah, this is a lot to take in, like in just one screen. Is it worth time? I mean, I don't know if you guys went through it last time. I
I
didn't
don't
join
think
the
so.
meeting.
Certainly not one by one.
Does
No,
it make
we
sense
didn't.
to do that? And Steve, getting back to what you were saying as far as looking at the MITRE attacks, how did that work? In my mind, what I'm thinking is you kind of go through the list, and I know there's a lot of them. I'm thinking like 60 or so from the last time I looked, which has probably been over a year. Did you go through them kind of like we did with the CSM, the CSA, CCM, and say, oh, confidential computing doesn't really apply here, it's orthogonal, and then find ones that, okay, here's one where this is definitely very much in flow for confidential computing. So let's take a look at just this one, or did you go through every single one and
So there's
make a comment?
1,200 of them, and we went through
Oof.
them one by one. Like I said, it took us months to go through it. We did it at the time, this is about 2 years ago. We did it at the time through the lens of SGX. And it was unilateral. We couldn't find anybody at MITRE that wanted to work with us on it. Probably just didn't knock on the correct doors. So we worked with a consultant to help get us started. And then we put this together as a white paper. And out of the 1,200, we identified 77 attacks that we thought we had a good mitigation against.
So you're saying of the 1,200 MITRE attacks, only 77 were mitigated by the use of SGX enclaves?
Correct.
Wow, I would have hoped for a higher percentage than that.
So the MITRE attacks cover everything, right? So before an actual attack even begins, there are MITRE attacks that cover planning, right? So an attacker is going to plan their attack, or an attacker is going to do research. Can I get a list of email addresses from the vendor so I know who to go spam? Right? Confidential computing isn't going to do anything for that whole set of categories of things. So there's the way I think of it is there's planning, there's getting in, there's staying in, and then there's doing what you want to do once you get in the door. But there's more, there's like 7 categories that MITRE puts those things in and breaks them through. And so it's really the getting in, right? So how do you do the escalation? How do you go from the workload to the OS, which confidential computing doesn't do much for. It works in the other direction. It's about the integrity guarantees of how do you protect the workload. And so an awful lot of the lateral movement is where confidential computing really had its sweet spot in the MITRE matrix. The integrity guarantees also popped up in funny places. But in those 1,200 attacks, some of them are Windows native, some of them are Linux native, and at least the way Injuna approaches confidential computing, we're a Linux-only shop. We don't do anything with Windows. Sorry, Microsoft, and certainly in the SGX world.
No offense taken.
In the SGX world, there are about 330 OS calls that you have to proxy as you want to interface with Linux between a workload and the OS. In a Windows operating system, there are thousands of operating system calls that you have to proxy. So you need a radically different approach to make SGX and Windows compatible than what we were taking.
Yeah, you know, that makes sense. And just for the record, hang on, give me 1 second. Let the record show.
What?
Yeah,
Oh, yeah, good one.
Okay, so I just had to set the record straight there. What I was thinking, Steve, was more down the lines of, I know MITRE's big into CSRF and those kinds of attacks where it's just completely orthogonal to confidential computing. Those are great attacks, but once you compromise a web app server, well then, you know, or an application, confidential computing, it just isn't involved in that threat at all. So I didn't know if that would winnow down the list of 1,200 to something that is, you know, more in our sweet spot.
It very much does, but it's not fair to say we cover 90% of the attacks that are in our sweet spot, right? Again, from a marketing point of view, why that would be a useful thing to say, but so our white paper really just focuses on, we cover 77 attacks and we don't mention the 1,200 that we don't cover. From an overall perspective, it's really intended as a conversation starter than a definitive guide for how to plan your threat protection.
Makes sense. And I'll stop monopolizing the conversation here. I'll
That's
just
okay.
say maybe the way I was framing it in my mind inappropriately is I'm cloud service provider. So I'm thinking, okay, of the things that confidential computing helps, it's really only helping shrink the surface of attacks when you're uploading your application into a public cloud. So from that perspective, it's if your only threat vector is cloud operators and infiltrators, then of those threats, which only apply if you're in a public cloud, of those threats that are specifically mitigated by confidential computing, we can take this percentage off the table and sort of wave off the ones that, hey, this is an attack that wouldn't matter whether you were in a public cloud or on-prem.
All right, let me throw
Steve,
up a much simpler chart.
Steve, could you send the paper you're talking about? Did you
I
do that
can.
with CSA? Was it published?
No, we did that unilaterally from Anjuna's perspective. We felt it was an important document for us to have. Would far rather redo it in concert with MITRE. We are a proprietary software application, but that's really because we don't think the market is ready for an open source piece of software in this space. We would have to invest in a whole bunch of community management and whatnot. But when it comes to white papers and the community work, we absolutely want to do that in concert with partners as opposed to doing it standalone. So I can dig up the white paper and I can commit us to working with MITRE to do something there. So
there's a bigger we here as well, right? Which is the CCC, or at least the GRC SIG. This seems that very much the sort of thing that the CCC should be thinking about doing.
Definitely.
Yeah.
So this PowerPoint was not the final PowerPoint. This was one early in the process as we were trying to get organized. But essentially, each one of the bullets: reconnaissance, resource development, initial access, execution, privilege escalation, credential access, persistence, defense evasion, discovery, lateral movement, collection, command and control, exfiltration, and impact. Those are the categories of MITRE's enterprise attacks. And we boiled those down, and Juna boiled those down into the 5 groups of planning, getting in, staying in, spreading, and goals. So these are what the attacker is ultimately after. As I mentioned, reconnaissance, resource development exist even outside of the network that's being attacked, right? So there's no play for confidential compute in any of those. Initial access, confidential computing has a play there because usually you're exploiting an application. There's some application that's presenting itself to the outside world, and you're looking for a vulnerability in that application. But since confidential computing doesn't protect it doesn't change the behavior of the application, it changes the behavior of the application's environment. The impact there is light, but there is some impact there. Privilege escalation, that's once you've attacked the application, how do you get to the OS? And there's not a huge amount there that confidential computing does. There's some in execution, there's some in credential access. This isn't a feature of confidential computing generally, but it's a feature of Injuna. One of the things we do, and I know your old company did it, Mike, was inject secrets into an environment after the environment has attested. So you don't have any of the secrets in the binaries to work with. You don't have any of the credentials lying around to be accessed until after it boots up and it can attest itself to have an integrity guarantee. Persistence, there is a lot that confidential computing does there. This is where you modify something that's on disk so that after a reboot, you come back. Generally, it's how do you get to stay in, and then how do you dodge, the various security controls that are in place. And again, integrity guarantees have a lot to do in there. Discovery, there's not much we can do there. If you've got a piece of code and now you're probing the network trying to find where you want to be. Think the SolarWinds hack, they didn't start out on the compiling machine. They got into the environment and then they spent a bunch of time probing until they could find a compiler and find the build machine. So that's what discovery is all about, and lateral movement is all about. We do a fair bit as confidential computing to stop lateral movement, because this really begins to look like another initial access. Once you get to a machine, can you spread to another machine and get to another workload? And then collecting, command and control, exfiltration, these all happen post attack. So once you've managed to get your foot in the door, now you're trying to do what you want to do. Again, confidential computing is going to have just a light play in those. So this is how we organized it from a high level perspective to think about it and talk about it.
I posted the the new threat, CPU stepping. Oh no, single stepping CPU attacks. I think the idea is that if I can slow down the processor, then I can glean information from either, and I struggle a little bit because I'm not sure I understand it yet.
Confidential computing should be an effective attack against single stepping.
Attack or defense?
Defense, sorry.
Okay.
And
There
why
were a
is
couple
that?
of there were a couple of papers published here in the last couple of weeks,
Yeah.
Steve, academic papers where they specifically attacked SCVS MP using, I think 8-bit and right. And then it wasn't, they didn't leak the actual keys. They weren't able to fetch the actual keys, but they did have a way to derive the contents of memory locations.
And also the
In a
platforms,
reasonable amount of times.
the platforms
thank you.
listed are not ones which are necessarily what we'd call T's and confidential computing. So AWS Nitro and Azure Titan, I'm not sure sit within that.
That's Google
definition.
Titan.
It says Azure Titan. I apologize. It's what it says in the thing. Effective platform, second paragraph.
Yep.
So it says Microsoft Titan Azure mitigations. Maybe there's some work needs to be done to tighten up the definition.
Or maybe I'm wrong. I've never heard of Azure Titan. Let me look.
And I don't see the Azure Titan. Are you looking at the,
I'm looking at the single-stepping-attack.md
oh, there it is.
affected platforms, and also
Azure
further
Titan
down
chip.
under mitigations.
Oh God, are there Azure Titan chips?
I'm-
Wow.
I'm
That could-
furiously looking.
That's a good, that could be a good catch for us.
I think it's a typo. That's okay.
So you think it should be GCP Titan rather than Azure Titan throughout? I think you may well be right.
TTP. Is there a TTP Titan?
TTP, GCP, I think we're saying.
Google.
Here we go.
So what's the so what would be the fix for the Azure Titan idea?
I don't think it exists. I think that's it should be talking about Google in that context, not about Microsoft, I think is what is being said here.
Oh,
Yeah, I don't think there's any such thing as Azure Titan or Microsoft
yeah, I don't
Titan.
either. Yeah, that's weird. Okay. We did use some AI to help on this. And it is in review. So this is the stuff we hope gets caught. Oh my God. There's Microsoft Titan documentation. What the hell is linked there? Oh, that page is not found. TPM.
Now that we're all about. We love our TPMs.
But TPMs are not TEs, so
Right.
Yeah, no. Well, depends who you ask.
no, they're not. No, they're not, because don't have generalized compute.
Well, they don't have generalized compute. That's true. But neither does a credit card, and Steve always loves to wave his credit cards around.
That's not a TE. Hardware-based TE in the context of confidential computing.
It's not
generalized compute. That's right. Totally in agreement.
I will give you that. Chris wants to say something.
I actually wanted to ask a question. I got here at the tail end of your analysis, and I wasn't sure what is the upshot. What's the takeaway of your findings there on the areas where CC helps or doesn't help?
Our takeaway was, I think anything that makes a significant dent in the attack surface is useful, and we wanted to use that as a conversation starter. So we boiled down the research that we did to a white paper, which is about 2 pages of mostly you should really be thinking about this, and I'll dig up the white paper and share it with the group here, and use that to get conversation started and get in the door from sales activity is what we were after. I think there's a stronger benefit to doing it in concert with MITRE, and doing it from the perspective of the CCC as opposed to doing it from the perspective of a single vendor. And then having some context out there that's industry-wide that says confidential computing is effective, and here's where it's effective, and it's not some vendor making a promise, but it's a community that represents.
That's exactly what we're here for, right? Absolutely. So we get the power of the industry rather than just one single. Not there's anything wrong with the single organization doing it, of course, but if we can amplify and bring more minds to it, that's great.
As the business that did it, there is something wrong with the business doing it. How much do you trust marketing that comes out of any corporation that's for the purpose of kicking off sales conversations? Right. You only put so much stock in that. And truthfully, I actually think confidential computing is super important in terms of reducing the attack surface, and I'd rather have it not come from a vendor.
Yeah, I mean, I that's a great motivation and a great study. I came in at the part where you went over the 15 items and really only attributed very light benefit to confidential computing, and so it seemed like it was more Well, it doesn't really help all that. The conclusion I was
don't
getting
think
is
I don't
it
think
doesn't
that was
help
what was
much.
being said. You may have missed it. I think what they're saying is there are a number of areas where it is irrelevant, but MITRE has 1,200 different things. In the areas where it does make a difference, it makes a big difference. I think that's where we're coming
That's
from.
right.
Is that there we go.
That is correct. And that message was not something you can put in a white paper, right? From a vendor that's trying to do sales. It's too nuanced, but that's something that I think is very strong coming from a group like MITRE, or a group like the CCC that can put the right kind of nuance on that. And so that was my point, because when I started out, I said Mark Novak started the conversation by thinking that, it could be used as pixie dust, that people will oversell it and say confidential computing solves MITRE. It does not. And MITRE is a very comprehensive look at the attackers and what they go through from long before they sit down at a keyboard to long after they've collected your data, and what are they doing with that data. And across that geography, there's only spots that confidential computing really fits into the overall framework. The framework didn't think of computers the way confidential computing thinks about computers. So there are attacks. It's not like there's an easy knock out these boxes. Even in the places you cover, you have to get nuanced into it that says we cover 6 of these known attacks as opposed to 12 of them. So there may be some work on the MITRE side to take some existing attacks and split them into 2. So confidential computing will cleanly cover this kind of attack, but not this kind of sub-attack.
Okay.
So may I just show, and again, I shared this before, but real quick, this is certainly my brain works tabular in a sense. So I wanted to show you what I was thinking in terms of how this would be organized. So here it is. This is my OneNote right here.
It's black.
And,
oh, there it's coming out. Sorry, it was just. It's too confidential before.
Yeah.
Sorry,
Okay, so here you go. So over left in here in increasing order by MITRE ID, these are the threads. And you can click on any of these threads, and there is a full explanation. This is all of them are hyperlinks to MITRE, right? So OS credential dumping, exfiltration over other masquerading, command and scripting interpreters. So this is interesting, right? So can we apply confidential computing to execution of scripts? Or Python, right? Like any interpreted language. And over here, I'm basically making a recommendation. You measure your script and you, issue credentials to that script. And then you can basically say, okay, this script, if unmodified, is going to be able to access whatever code that script needs to access, right? And you go down the list. Now, I'm not claiming that my analysis is even correct, but we can find the parts of MITRE that confidential computing can help with, and then we can recommend confidential computing as a control for these particular MITRE attack IDs.
Yes, exactly.
Yeah, that's what I'm hoping to accomplish, and
that's
publish this as a guide, carefully reviewed, basically, and ensure that it's comprehensive and it's not missing anything.
Yep.
And that's exactly what we did previously internally here that I'd love to redo with both CVMs and as an industry perspective.
Yeah,
Right.
yeah, agreed.
So
happy
that's
to
the list I already
participate in that.
emailed. You already have it, but that's, we need output like that, and I would like to perhaps dedicate some cycles in this working group after we're done with the current set of patterns, which will actually close to done for the time being anyway. Then we can dedicate time, resources to authoring it, getting it reviewed, maybe having MITRE look at it, maybe Mari can help us with that. And then, aim to, in a few months, publish it as our official guide.
Yeah, I really like that.
Yeah, me too.
Okay. Let's resolve to do that. Now, we're about halfway through, just over halfway. I would like to now switch attention to our verifier governance document. So this is what I'm hoping we're going to do. Like as the first message in today's chat, I put in the link to the document that I'm now going to share on the screen. And what I would like us to do is scan over it in the next maybe 5 minutes, Amazon style, where you just go into a meeting and you read the document online. It's short. It's literally 2 pages.
Could you can make the sides go in where it's tiny as we're seeing.
Yeah, but you can also open your own link. I will zoom. It's in chat as the top link. The very first message I put in chat.
Okay, got it. Thank you very much indeed.
But this way you can put in your own message, messages, etc. And I changed all the I changed all the language to match the RATS terminology.
Cool.
All right, so 5 minutes and then we'll be back.
Could I have access, please? I've just sent a request.
Wait, where are we going? We're leaving?
No. I'm just saying 5 minutes to review this document.
Yeah.
I can paste the link back in the chat for you, so you don't have to scroll. Where do I do that? There we go. Do I do that? The chat. There we go. So let's review this and come back in 5.
Bye, Sal. Bye, Sal.
Yeah, bye, Sal.
Okay, bye-bye.
Thank you. What is the document?
Called Verify Governance.
Verify governance. How does it apply?
So the verify is the attestation verification piece, basically. Component in the system.
Mark, I'm getting an access error. Could you check your inbox for request?
Mark, have you read the new version of the attestation, the AVS business models document yet?
I don't believe
because there's a number of things in there which may be helpful in terms of this, in particularly in the who should I trust to run an AVS section.
Okay. Well, we can reference it from this document too.
Yeah, sure. Well, it's far from complete, so.
Okay, well, once done. I mean, these can be living documents.
Partly because Alec is asking lots of interesting and difficult questions at the moment, so it's just fun.
Okay.
Got an axe to grind.
I've noticed. That's fine. I don't mind grinding axes. I've got loads of them.
It's a good doc, and it's a conversation that is very, very much needed. So thanks for making us.
No, that's good. I'm really happy to be having it. Don't you know? I'm really not stressed about it. It's great.
I love to hear that.
Please get involved in this conversation as well. Everyone.
I just love to hear. I'm pleased to hear about it.
Well, put the link in. Put it maybe in the.
Oh yeah, sure.
To the list. Email it to the list so we can all review it.
Let's see if I've got a link to the list. I think most of you have already received an email. I thought you had. What's the status? GRC is the name of the link. GRC lists. There we go. There we go. Thank you.
Okay. So our 5 minutes are up. And first I want to do a quick room temperature check. How close to done do we think this is?
I need another couple of minutes.
Okay, let's do that.
My answer to your question is I don't know, Mark, because I don't know what counts as done for the consumers of this. So I don't feel in a position. I think it holds together as what it is, but I don't know whether it's what's needed by the people who are going to consume it. So I don't feel qualified to answer your question fully. I apologize.
What's my question?
How close to done is this was your question.
Well, just, do we feel, how close to where we feel this can be published and consumed? That's done.
No, that's fair. That's fair. I'm disappearing briefly, but I will be listening in.
I'm done now, Mark. Thanks for your patience.
Yeah.
I think it's a great doc.
Fantastic.
I agree with everything. Just a couple of nits, just to prove that I read it.
Okay, I responded to your comments.
There was one little section that maybe could use words. You talk a lot about verifier policies. In the case of verification services that are provided in public clouds, certainly the CSP owns some policies that affect the functioning of the verification service, but then the tenants have policies as well that
I believe that is mentioned. Let me find the place where this is mentioned. Under forces in 3, we talk about verifier policies and policies related to administration of the verifier itself.
Got it. Can we say relying party policies?
This is not a relying party, though. There is nothing here about relying parties.
Then, okay. And I think maybe that's what I was expecting, like, especially down in the solutions section. Because you talk about how we have to have integrity of the verifier policies, which is very true. But if I'm a relying party, then I have some attestation policies that I would upload to the verifier. Well, here's the way it works in Microsoft. So it's what I'm familiar with, and maybe there's just a missing spot in my understanding because all I know is Microsoft. The way I see it is customers upload key release policies and they say, hey, if the attestation claims don't match these reference values, then please don't consider this T to be secure and don't release my keys to it. So I see those as policies that are owned by the relying party, and different relying parties might have different reference values. So for example, I might be fine with firmware version 28 from AMD, whereas other people might say, no, 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 there's a specific risk in 28. I want it to be firmware version 29. And so we have different policies there.
Right, but so when you're governing the verifier, when you're doing governance of the verifier, that governance is limited to the policies verifier maintains, right? So if you're worried about the policies that exist on the relying party, then it's relying party governance. And that's a separate discussion that we're actually going to have in terms of how do you make sure that the relying party policy stays constant, because there are many, many relying parties, while the workloads might get updated. And that's actually covered in part by existing documents, and it's going to be covered further as we talk about attestation integration with identity and access management,
So
which today is like not done correctly.
So really specifically, if I'm the relying party, I own my relying party policies, but I store my policies in the attestation verification service. That means it's up to the attestation verification service to provide integrity guarantees for my policies. Okay, but you're saying that belongs in a different document.
Yes.
Yeah. Okay,
Okay.
and that addresses my question, because I was going to point out when you get into the availability and the integrity of the verifier itself, that or how much do you trust the verifier itself? The attestation verification, the integrity guarantees of the workload can be done via multiple verifiers. The policy, of course, is only going to be in a single one. You're only going to pull policy down once and make decisions, and that is the focus of the AVS as we've defined it. But there is this separate function of the integrity verification that if you're worried about that being exploited, you can do that via multiple sources. You can use MAA and ITA, and only pull down your policy from one, but you can do an integrity check against both.
Mm-hmm. Okay.
But I think you covered that the remote attestation is independent of
I
what
believe,
you're defining
so
as the
we're
AVS.
trying to have our governance be done in orthogonal pieces, and when it comes to integration of how we integrate attestation verification with relying parties, right now it's all wrong. I mean, to the first order approximation, and I want to change it all. And I want us to start thinking about workload identities and integration with IAM, and I will be pushing for that relentlessly until I get my way. I can be very stubborn that way. So that's a separate discussion. I invite you to the next meeting of the attestation SIG. I'm sending them a white paper, and we'll be going through that. We should be not thinking about workload identity any different than we think about user identity for most intents and purposes. And we just, like, right now, it's architecturally just screwed up. We'll change that.
I'll look forward. And that is the attestation SIG every week, or is it every other week?
Every other week. It's Tuesdays. So there was one yesterday, and there was another one 2 weeks from yesterday.
Okay.
So the next one's going to be in November. Yeah.
Okay, cool.
Yeah, and
I
will be again. I
attend.
already got me on the calendar for that. There is a zero trust angle, as I already discussed, and all of that. So anyway, so going through this, I think we should still figure out how to align this with the privacy considerations. So there is a comment from Hank Berkholz, who I believe is one of the RATS editors, RATS authors. So we can either reference privacy considerations, or we can explicitly pull some of them in. There is a couple of comments from Alec. I responded, so if you're comfortable with my response, please go ahead and resolve. There was a comment from Thomas Fasati on the history of reference values related to supply chain. I don't know how to. We should probably discuss that here in the remaining time. And then comments from Mohammed. We're going to. So I already addressed performance and scalability, so that one's done. So relying party policies, like we already discussed, they belong elsewhere. Peer. I will just peer tenant isolation is what I meant to say. I'll change that.
Cool. Then we're good. The rest I've already resolved.
And there is a question about under 3, solution number 3. There is a should that I'm asking if it should be a must.
Where's that on number 3?
Solution bullet 3.
Looks like a must.
Is a very, very strong one that basically requires every attestation provider to do it. And should was more like, if you don't do it, consider, the problems you might be facing.
I do love a must, but yeah, tricky. I don't know.
I'll abstain.
We can move it to must if anybody objects, Then we'll have to question their motives.
I abstain.
Let's do must.
I'm not sure abstention is safe.
You guys have to forgive me for not reviewing that document right now, because I had to I have to work on fixing that threat.
No worries.
Okay, you can do it offline.
Yeah.
We're quite forgiving most of the time.
Hey, Mark,
thank you.
If I can just grab a couple of minutes here at the end, save me like 2 minutes. I wanted to ask you questions about the CCM.
No, we can stay past the end of the top of the hour if you want.
Cool. I just basically wanted an update. The entire group might enjoy hearing an update. I understand that you attended a meeting. I was hoping, I think maybe I missed your mail on the invite, but I guess there was a meeting with the CCM authors and they considered adding new controls for confidential computing. I was wondering if you attended the meeting, and if so, how it went.
The UEM one was very obvious that we're not ready to proceed because it's the one on CEK. I think they're actually quite amenable to introducing data and use protections using approved hardware, approved ciphers. So the worksheet that they're working on right now probably contains the latest. I need to see because all the inputs must be in by this Friday. So I will check to see what stage it's in. But so far, the CEK and the IAM domains appear to be amenable.
Cool. If there's anything that we can help with or review or whatever,
yeah, I need
don't
to open that worksheet probably ahead of Friday because Friday is the deadline, and see if there is any emergency intervention necessary. I'll pull you in if need be.
Yeah, somehow I fell out of the loop on that. So if you
okay.
Or is it the same worksheet that Lefteris shared with us a long time ago, and it's just the same one that's still under review?
Well, it's not really a long time ago, maybe a couple of weeks ago, but yeah.
No, the last one I got was probably a couple of months ago.
No. You would have gotten it in September. So it's a worksheet. I need to pull it up. Let's see if I have it in my Google Drive. Right.
So I have another exciting meeting coming up in a couple of minutes. So, of course, not as exciting as this one, but I am going to need to. Really, it's not. I'm going to need to leave fairly soon. I see Chris has got his hand up, by the way.
I just put a link to the CCM 4.1 worksheet in the, please read the instructions carefully before making any changes. You may need to request access, but Lefteris will grant you access if you explain that you're part of the GRC SIG.
Cool.
All right. So I think we are
Okay.
in a place where I'm ready to take this to the attestation SIG. Steve, I still need to see your.
So I note that Chris has his hand up. He's muted as well,
Oh.
but he has his hand up. I just
Chris,
thought-
please speak up.
Maybe put your mic on live.
No, you are mute at the moment.
Hi, Chris. Okay,
Maybe it's a stale hand.
maybe.
Sounds
Could
painful.
be.
Yeah, Mark, I requested access to both documents you posted, this governance one and the last one.
Yeah, the last one I don't control access, but the governance one, I see. Okay, so Mari just requested access, which I'm going to grant.
Cool.
Okay, Mari, you now have access. I apologize, I didn't see that sooner.
Oh, no sweat.
Well, I'm off, folks. Have a good one. Thanks a lot.
Okay.
Really
Ditto.
interesting meeting. Really appreciate it. Good stuff. See
Yeah,
ya.
this is really good. I'm glad that we're making progress. This group makes good progress.
Well, that's the plan. All right, so, okay. So Steve, to your comment on having multiple verifiers, if they're multiple, then you need to govern them separately.
They are, but the I just you were talking about the integrity guarantees of the verifier itself, and the verifier performs two functions. Obviously, it's verifying the integrity of the workload and then providing secrets to the workload. And those are two functions, and the availability can be done independently for those two.
Wait. How is verifier providing secrets to the workload?
It's all the information you're providing about policy, right? It's going to make a policy decision, and then based on the policy decision, it's going to grant, do this, don't do that, right? Those are essentially passing information back to the workload.
How is that part of high availability?
Yeah, maybe I tagged it in the wrong place. All I was trying to say was the integrity check,
Oh,
where you
shoot.
establish the
I'm gonna have to go,
integrity
guys.
of the workload.
All right.
That can be verified
Love.
independently by a second verifier from the policy decisions.
I do not follow. I'm sorry.
Okay, we can do this on the next one then. It's a small comment. Don't worry about it too much.
Well, you can suggest a change and then we can review it. Just put a suggestion into the document.
Okay.
Okay. Chris said there was a comment in the doc and having a problem with the mic, which I think actually, Chris, I addressed your comment. I basically said pretend logs. I added that. Okay, I think we're out of time, so we're going to wrap it up here. I think at this point in time we are pretty much ready. The only thing I will say, the privacy considerations in the RFC talk about also confidentiality of attestation results, because they can be reverse engineered towards you know, what the policy might in response to Hank's comment. So that will do. But for the most part, I think we can send it over to Attestation SIG and ask them to bless it. And then we'll be done with this one. And then I think we should be moving into MITRE next. And basically have some working sessions where we pick some of the MITRE attacks and discuss guidance that we might want to provide. And if you guys have done some work, so I think you have a white paper. So we should
I
start
attached the
with
white paper
existing.
to,
I see
I
that.
attached
I
the
see
white
that.
paper in here, and it's going to be higher level than what you're looking for. I'll have to dig out to see if the old notes we
Mhm.
have are still around from when
Yeah,
we did the
whatever
exercise.
prior art we have, we should reuse. Otherwise, we'll just go and author the guidance we need, and perhaps Mina can help us out. All right.
But I
Thank
mentioned
you
this was
all.
this was done with a SGX basis, and we're probably going to need to do it from a CVM, which is where the
Absolutely.
industry's at.
Absolutely. Okay. Sounds good.
Okay.
Well, thank you all. We'll see you again in a couple of weeks, and come
good.
to the Attestation SIG if you want to discuss relying party integration and identity access management.
Hey, Mark, is Greg Costel, my colleague, pretty active
Yes.
in that discussion?
Yes.
All right, cool.
Yes.
Awesome.
Yeah, and I
Thank-
said I'm going to also talk to him offline. Maybe the three of us can have a discussion offline separately.
Sounds great.
All right. Take care.
All right. Bye-bye.
Bye-bye.